Hi everyone, I'd like to talk a little bit about polynomials and the distributive property in this one. So this is for 2.1.1. So polynomials, I just want to do a quick version of this. I don't want to get too into messy looking notation that you'll sometimes see when someone's trying to define a polynomial. So I'm just going to say that a polynomial is a sum whose terms contain only coefficients and variables with positive integer powers. So sum means that it's things added together, right? So we're adding things up. And terms are the things that we are adding together. So this is vocab as we go along as well. Again, you're getting the very casual version. And these should only have a coefficient times a variable, or it can even be more than one variable, to power, and we want the power to be a positive integer. So polynomials look like, I don't know, 3x to the fourth minus x squared plus 7x plus 4. Notice that that last one sometimes throws people off a little. It's supposed to be a coefficient times a variable. Ooh, I'm even going to change my definition a little bit. I tried to do the casual one and it's almost right. Okay, we'll say non-negative power because we can think about the constant term in a polynomial as being multiplied by x to the 0, which is really just 1. So that's how we kind of mentally compensate in our definitions for the fact that there can be a constant term. Okay, so again, just to clarify some of these things. So sum, and it can be a difference, or you can think about it as the subtractions are adding negative numbers, however you want to think about that. So sum or difference means we're adding and subtracting things. When you add and subtract things, those individual things are called terms. So I see 4 terms. And this is actually really important. I don't like to pick on a lot of math vocab if I can help it, but I would say term, factor versus term, is going to be really important. I'll contrast those in just a second. So terms are attached by addition and subtraction. And within each term, I should see a coefficient. So in the first term, the coefficient is 3. In the second one, it's 1. In the third one, it's 7. In the last one, it's 4. So a coefficient is a constant that's multiplied by your variable or expression. And then you should have your variable, and your variable should not have fractional powers, should not have negative powers. It should have non-negative integer powers. And again, the non-negative is just to allow for this imaginary x to the 0 over here. Okay, so this is what polynomials look like. And polynomials, hopefully you've seen before, you've done operations on polynomials before, but they're kind of the building blocks for rational functions. So we want to make sure we have some of this notation and vocabulary down. Okay, so this first part of this section, we're going to look at 3 different ways to rewrite polynomials. Well, 2 for polynomials and 1 specifically for quadratics, which are polynomials. So first we're going to look at the distributive property. And I'm kind of sneaking in some operations here because the distributive property is really about multiplying things. So distributive property says, and again, I hope this one is familiar, if you are multiplying a number or an expression by a sum or difference, doesn't really matter. So again, be really thoughtful about that sum of 2 terms. You can distribute. You can change that from the product of 2 factors. Since this is multiplication, we're looking at a product, and the pieces of a product are called factors, to the sum of 2 terms, right? So the distributive property is all about rewriting a product as a sum. And specifically what I want to look at here is rewriting a product as a polynomial, which polynomials are always sums, but what you should see, you should have those nice positive integer powers. Be really, really careful with the distributive property. People want to use it everywhere. If you'll remember, roots don't distribute. Roots do not play nicely with addition and subtraction. They will distribute over multiplication, but not over addition and subtraction. There are very few things that distribute nicely like this. So only when you're multiplying a sum. Multiplication, because it's really a repeated addition subtraction, plays nicely with addition subtraction. So there's this kind of one step between operations that'll work nicely. Okay, so I think maybe that covers our intro stuff. So again, factor versus term, think about that a lot. That's important. And the idea there would be if you're looking at a product, so in the first one we have a product, you're multiplying factors, right? So that's the product of two factors. If you're looking at a sum or a difference, where the big operation is the addition subtraction, you're looking at two terms. And interestingly, it can get a little confusing, right? Because in our product at the top, one of the factors is a sum, and in our sum at the bottom, both of our factors are products. So really this boils down to, I call it the big operation, right? The big operation in the top is multiplication, the big operation in the bottom is addition. It's order of operations. The thing you would do last is the big operation. So in the first one, parentheses force us to add first and then multiply last. So the big operation is multiplication. In the second one, order of operation forces us to multiply first and add or subtract last. So this is really an order of operations question. Okay, so I'm going to run through some examples. Again, if you feel good about distributing, feel free to skip this. We're going to go up to having 3 terms within a factor. So if you need to see some messy ones, they're here. Okay, so first one, this one's fairly well behaved. Whenever one of your factors has only one term, so here 2x, there's no addition or subtraction in that. That's called a monomial, only one term. I don't super care if you remember this monomial, binomial, trinomial, but we will use it kind of regularly. So monomial is one term. Once you figure out the term part, they're pretty predictable. Binomial is 2 terms. And trinomial is 3 terms. So here we're multiplying a monomial by a trinomial. This is a product, and within the product there is a sum or a difference. So the distributive property applies. It says I can rewrite, and I did write the distributive property with only a monomial and a binomial, but it applies regardless. So here we can distribute across a sum and a difference. So we're going to say, okay, I need to multiply my x cubed by the 2x. You don't need to write this step out for me. I just want to compare it down below. The 4x squared by the 2x and the 7 by the 2x. And doing that multiplication, so again, notice we're sort of out of order. We're just supposed to be changing appearances, but we're doing some multiplying and dividing along the way. So we have 2x to the 4th, right? We add powers. We have minus 8x to the 3rd, and we have 14 x's. Okay, so distributive property applied to a monomial multiplied by a trinomial. The next example is a binomial multiplied by a binomial. You may know the shortcut FOIL, and you are welcome to use it. I have no problems with it, but FOIL doesn't generalize, so I'm going to use the distributive property all the way through so that you can see that it always boils down to the distributive property. So here, I'm going to mentally, you can go either direction, but I'm going to mentally kind of glue that together and think about it as my single factor, while I'm thinking about the second one as my sum of 2 terms. And I'm going to distribute through So I'm going to get my 5x times 2x squared minus x, and then I'm going to get my 4 times 2x squared minus x, and that's going to give me, I get to distribute yet again. So see, always boils down to distributive property. That's really all that FOIL is a shortcut for what happens. So I get a 10x to the third minus 5x squared plus 8x squared minus 4x. And I can actually simplify this one a little bit. So again, some operations sneaking in here. Because polynomials are supposed to be review, I'm hoping that doesn't give you trouble, but let me know if it does. So we can combine like terms. Remember, addition and subtraction is always about like terms. So once you throw variables in the mix, like terms means that it's the exact same variable part. So x squareds are the exact same size. So I can say I have 8x squareds minus 5x squareds. That leaves me with 3x squareds. I can't say I have 10x cubes and I'm going to take away 4x's from that in any simpler way, because x cubes and x's aren't the same size, so I can't just count up how many x cubes or x's in that case. So we'll leave it right here. Okay, next example, I'm going to start switching colors so this is easier to see. I'm going to do the same thing, and again, you can do it either direction, just sort of habit because of the way we write distributive property. I often take the the factor on the left, listen to me making that mistake, and glue it together in my mind, and then mentally look at the second thing, the thing on the left, as the sum of terms. So I have 3 terms that I need to distribute through. So I'll get a 3x squared multiplied by a 2 minus x cubed. I will get 4x multiplied by a 2 minus x cubed. And I will get a 1 multiplied by a 2 minus x cubed. And if you get good at this and you can keep track of it in your head, totally fine with me. I'm going to write it out very carefully for now because I think a lot of us need to practice that before we start being crazy about what we do in our head. Okay, so then we do a second distributive term, or distributive property. My dog is trying to help me right now. Don't mind if I'm distracted. For each of these, oh, except I'm being silly here. So for the last one, you can do that, but it's not really necessary, right? We're multiplying by 1, so those parentheses are really pretty meaningless. Parentheses are important if you have an operation attached to them, so a multiplication or a power, something like that, but they're not needed for addition. Parentheses for certain orders, and addition, subtraction can happen in whatever order. Although I should be careful there. Subtraction, that minus sign does need to attach to both terms. Okay, so then 3x squared times x cubed, so we're multiplying 2x's by 3 more. We're going to get 3x to the 5th. 4x times 2 is 8x. 4x times x cubed, okay, so we're multiplying 1x by 3 more, that's 4 of them. And then plus 2 minus x cubed. Okay, so again, we probably ended up with some like terms. Ooh, did we? We have a squared, a 5th, an x, a 4th, a 2, and a cube. Maybe we didn't. We might not have. Okay, I'm going to rearrange these, and you're going to see some of this in your homework. I didn't mention it, but I did do it in the last one as well. I'm going to write these in descending order. Let me say that I could care less if you write things in descending order, but you'll see some of that in your WAMAP homework, and this is really kind of a byproduct of the fact that it can be difficult to get a computer to check expressions. So descending order just means you put the biggest power first, and then you write them in order. So the 5th power, then the 4th power, then the 3rd power, then the 2nd power plus, then the 1st power, and then the constant. So some of your homework, I believe, says write in descending order. That's all it means, is put the biggest power first and then decrease as you go. And you can see the last two, I did do that. I didn't think to say it until now, but that is something that's not a bad habit for the computerized homework piece. Oh, this last one, we only need 3. Ignore that one, it's the first one all over again. So this is going to be the idea, and you'll have variations on this, but what I want you to remember is that it's always about the distributive property. When you're multiplying and one of your factors has more than one term, distribute. It doesn't matter if it's 3 terms or 4 terms or 2 terms. Sometimes you'll have to repeat it, but that's really all it boils down to. So rewriting products as polynomials. Thanks for watching.